All right, let's blast off and tackle one of the biggest questions imaginable. What could alien life actually be made of? And I mean, let's forget the movies for a minute, because we're about to dive into the real, hard science and chemistry that astrobiologists are wrestling with right now. And we're going to start by throwing a wrench in our most basic assumption about life. We all learn it as kids, water is life. And yeah, for us on Earth, that's absolutely true. But is it a rule for the entire universe? Could life out there be swimming in an ocean of something else? To even begin to answer that, we have to look at our own instruction manual first. Before we can even think about breaking the rules of biology, we first have to understand why those rules work so well for us here on Earth. And our blueprint, well, it's actually pretty simple. Life, as we know it, is built from amazing carbon-based molecules, and all the action happens in water. It's our gold standard because, hey, it clearly works. But here's the kicker. It's the only example we have, a sample size of 1. Which makes you wonder, does the universe have any other recipes? So, what would it take to replace water? Well, think of it like a job application for solvent for life. Any liquid that wants the gig has to meet a few key requirements. First, it's got to be able to dissolve a whole bunch of different chemicals to get that rich primordial soup going. Second, it needs to be stable, but not, boring. It can't be so stable that nothing ever happens. And third, and this one's a biggie, there has to be a lot of it on a planet. Okay, with those rules in mind, let's take a little cosmic road trip. We're going to visit a few worlds where the oceans aren't made of water, but of stuff that's way, way more exotic. Our first stop is deep beneath the ice of a moon orbiting Jupiter, let's say. Here, the #1 contender to replace water is liquid ammonia. And you know what? It's a pretty good solvent, and it's all over the place in these cold outer reaches. The main drawback? In that kind of freezing environment, chemical reactions would happen in super slow motion. The leap from simple chemistry to complex life would be a massive hurdle. It's plausible, sure, but any life there would be living life in the very, very slow lane. Next up, we're off to Saturn's giant moon, Titan. And this isn't just theory, we have pictures. Titan has actual real-life lakes and seas of liquid methane and ethane. Now, it is ridiculously cold there, about minus 180 degrees Celsius, so again, any life would be moving at a glacial pace. But, and this is wild, scientists have theorized that you could build cell membranes there. They're called azotosomes, and they'd be flexible, stable bubbles made of nitrogen compounds that could work just like our cells. It's just a completely alien but strangely plausible idea. For our final stop, let's go somewhere truly out there, the clouds of Venus. The potential solvent here isn't water, it's droplets of concentrated sulfuric acid. Okay, this is an extreme long shot. This stuff is so corrosive it would tear apart most molecules that we associate with life. But it is a very high-energy environment. So if, and it's a huge if, life could evolve using a completely different acid-proof chemical toolkit, this is the kind of hellscape where you might find it. So we've talked about swapping out the liquid that life lives in. But what about the building blocks themselves? What if you swap out carbon? When you ask that question, one element always comes up. It's the classic sci-fi celebrity, silicon. And you can totally see why. Just look at where it is on the periodic table. It's sitting right below carbon, like its chemical cousin. Just like carbon, it can form 4 bonds, which is crucial for building long, complex chains. And it's unbelievably common. Rocky planets are practically made of this stuff. So on paper, it looks like a perfect substitute. But as is so often the case, chemistry is all in the details. And when you look closely, that beautiful dream of a silicon-based life form, well, it starts to crumble under the harsh light of reality. Silicon has some pretty big problems. First off, the bonds it makes with itself are just weaker than carbon-carbon bonds. That means long, complex molecules you'd need for something like DNA or proteins would be super fragile and would probably just fall apart. It also does not play well with water. Water tends to attack and break down its compounds. Bottom line, silicon chemistry just isn't as tough or as flexible as carbon's. But honestly, those aren't even its biggest flaw. The true deal breaker, the absolute showstopper for silicon life on any planet that looks anything like Earth, happens when it tries to do the most basic thing imaginable: take a breath. And this is the critical point. For a silicon-based creature living on a planet with oxygen, that simple act of breathing would be a fatal, one-time-only event. Why? Because that process would literally, and I do mean literally, turn its insides into solid rock. And here's why that is. When we carbon-based creatures metabolize, we combine carbon with oxygen, and our waste product is carbon dioxide, a gas. We just breathe it out, no problem. But if a silicon creature combines silicon with oxygen, its waste product is silicon dioxide. That's not a gas. That is a solid mineral. It's quartz. It's sand. You can't exhale a rock. Game over. So after a fatal flaw like that, where does that leave our search for truly weird life? Is there any hope left, or is the universe really just stuck with our carbon and water recipe? Well, for silicon, there might be a few tiny, very strange windows of opportunity. It could theoretically work, but only in an environment with no water, so its molecules don't break down, and absolutely no oxygen, so it doesn't turn itself into a statue. We're talking about places that are either incredibly cold, like Titan, or unimaginably hot, maybe even inside molten rock, where the rules of chemistry just get plain weird. So let's bring it all home. Based on what we know right now, here are the top contenders on our alien life leaderboard. For the best overall substitute for water, the winner is probably liquid ammonia. For the best real place that we can actually go and study, that's got to be the methane seas of Titan. And for the most extreme, out there but still possible idea, that would be the sulfuric acid clouds of Venus. And all of this leaves us with one final, huge question to think about. Our entire search for life out there is based on finding the chemical fingerprints of life as we know it. But if life can be this profoundly strange, built from a totally different rulebook in a world with methane for oceans, are we even looking for the right signs? It's a question that reminds us to keep an open mind, because the universe might just be a whole lot more creative than we can even imagine.